Hello everyone. Today we are going to see the one more example of part programming. Now, today we are going to see the part programming for a milling operation. Okay. So, in this program, you can see the given part and the given path also that we are supposed to remove the material in L shape by using a end mill cutter. Okay. And the plate is given, which is having a 40 by 35 mm, having 10 mm thickness. Okay, and the material which is removed by this plate is having a L shape by using a end mill cutter. Okay, so here you can see all the dimensions are in mm. Now first line, that is P1, that is a program identification number N005. Okay, this is sequence number, but before that I am going to tell you once again that in any part program there are three major parts. One is for program setup, second is for chip removal, and third is for a system shutdown. Okay, so first we are going to do a first part, that is program setup. Okay, so N005, here I have taken N005, but if you want you can take as a N001, N00, N0010, N0020, N0030, N0040. Okay, so N005, M06. M06 is nothing but a tool change. Okay, tool change to our current tool, which we set to T01. Okay, if any tool is there already, that we are going to change to our tool, our end mill cutter, which is at T01. Okay, so first step, that we change the tool to our tool. Now we are going to give a speed to a spindle, in which direction it is going to rotate, whether clockwise or anti-clockwise. So next step is N010, N03, S400. Here you can either use S or you can directly enter the RPM also. So M03 is the spindle rotates in clockwise direction, which is having a 400 RPM. Okay, so the next step, that is we are going to move a tool to a designated position, initial position. Okay, so next step is N015, Z00, that is for a rapid transfers. X10, you can see the coordinate X10, Y 37.50, Z 2.5. Okay, and the XY feed is 200 mm per minute. Okay, now here our tool is at initial position. Okay, now we are going to give a cut by reducing in a Z axis. Okay, by lowering the Z axis. Next, that is N020, Z01. Okay, G01 is for a linear interpolation, Z01, X10, Y 37.50, Z minus 5, Z feed 100 mm per minute. Okay, so here I have taken directly a 5 mm depth of cut. We will see later if we take 1 mm, then what happens, that we will see later on. Okay, so our cutter is moved in downward direction. Okay, so here the feed starts. Now second position we are going to give. Okay, so second position is N025, Z01, X10, Y 7.5, Z minus 5, XY feed 100 mm per minute. Okay, that means our cutter should move in downward direction to the corner of this L shape. Okay, so currently the position of this cutter is at the corner of the L shape. Okay, now we are going to give the instruction that it should move horizontally towards right side. So the next program, that is N030Z01 X35 Y 7.5 Z minus 5 X5 feed 100 per minute. Okay, in such a way our L shape cutting is completed. Okay, now we are going to remove our cutter or retractor to position. Okay, so the next instruction we are supposed to give it to the machine, that is N035 Z00 X35 Y 7.5 Z 2.5 Z feet 200 per minute. That is, it is going to retract a position, okay, above the workpiece. Now we are supposed to move it to its initial position, that is N040 G00 X10 Y 37.50 Z 2.5 X5 feed 200 per minute. Okay, in such a way we have removed the material. That is, we have finished the second part of the programming, that is a G removal. Okay, now after that the cutter came to a starting position. Now we are supposed to stop the spindle position, so we are going to insert a block to stop the spindle. Okay, that is N045 M05 to stop the spindle. Now here our operation is performed. Now we are supposed to mention the end of the block, that is N050 M02. M02 is for a end of the block. Okay, so in such a way you can do the programming for a milling operation. Now I am going to repeat the codes which we have used in the milling operation. So P1 is for our identification number, P, N is the sequential number, M06 code is for a tool change, T01 is for a tool to select the tool, M03 is a for spindle clockwise direction. Okay, this code is for a spindle rotation in clockwise direction, G00 for a rapid transfers, Z01 for linear interpolation. Okay, M05 spindle stop. Okay, M05 code uses for a spindle stop, M02 uses for the end of the block. Okay, now here if you observe, I have taken directly a 5 cut, but here you can do the programming in another way also. Instead of, if you see the block N020, here I have taken Z01 X10 Y 37.50 Z minus 5. So instead of this minus 5 you can take minus 1 also. Okay, in such a way you can repeat this cycle from N020 to N040 5 times, sorry, 4 times. First this you have completed and you are supposed to do it for remaining 4 times. So total 5 times you remove the material, that is 1 mm each time. That means 5 mm you can remove the material from this plate. Okay, so here you can see I'm going to repeat it once again how the program is there, but before that let us see the parts description. Okay, so initially the plate is given, which is having 40 by 35 by 10, that is 40, it means 40 by 35 plate having 10 thickness. Okay, and in this we are supposed to make a L shape cut having a 5 mm width by using the 5 mm end mill cutter, 5 mm diameter end mill cutter. Okay, here the tools start position is given. Okay, so now we are supposed to start the programming. Here P1. Okay, P1 is program identification number. Next step, sequence number N005 M06, that is for a tool change. If any previous tool is there, we are going to change it to our current tool. Okay, which we hold at a T01 end mill cutter. Okay, now after that we have selected our tool. Now we are going to give the speed to a uh, give the speed and direction to the spindle. Okay, so in next block N010 M03, that is spindle clockwise direction, which is having a 400 rpm. Okay, here you can either write yes or it is okay, you can go also M03 400. In such a way you can also write. Now next N015, here we are going to place the tool at our initial position. Okay, Z00 for rapid transfers, X10, Y37.50, Z2.5, X5 feet 200 per minute. So in such a way we are going to place the our cutter at initial position. Okay, now we are going to lower the cutter. Okay, here I am going to explain the axis. The 40 mm edge is a horizontal, that is x direction. 35 mm side edge is y axis, and the vertical, the spindle, the end mill cutter's axis is a z axis. Okay, so any vertical movement is a z axis movement, that is cutter's movement. Okay, so here we the reduce the cutter. Okay, cutter height by 5 mm. Here I have taken directly the 5 mm depth. Okay, so here you can see in N020 Z01 X10 Y37.50 Z minus 5 having a Z feed 100 mm per minute. Okay, here the feed you can take as per your convenience if it is not given. Okay, now next the cutter should move in a downward direction. Okay, to remove the material in vertical way. Okay, so we are supposed to mention the next coordinate, that is we have mentioned that is N025 Z01 X10 Y7.5 Z minus 5 XY feed 100. Okay, in such a way our cutter is now at the corner of the L shape, or at the bottom of the cutting edge. You can see the coordinate 10 and 7.5 over here. Okay, now we are going to move the cutter in a horizontal direction. So here you can see the next block, that is N030 G01 X35 Y7.5 Z minus 5 XY feed 100. Okay, now in such a way we have completed the cutting, we have completed the L shape cutting. Now we are supposed to retract a tool position. So next block is for a retracting a tool position, that is N035 G00 X35 Y7.5 Z2.5 Z feed 200 mm per minute. In such a way tool is retracted and it is above the workpiece. Now we are going to shift the cutter to its original or initial position. Okay, that is we have did N040 G00 X10 Y37.50 Z 2.5 X5 feed 200 mm per minute. Now our cutter is came to initial position. Okay, but still it is rotating, spindle is rotating. So next we are going to stop the spindle. So for that we are supposed to give a next code, that is next in we have given it in next block N045 M05. Okay, M05 for a spindle stop. Okay, so in such a way the block is completed. Now we are supposed to give a code to the machine, that is the end of block is there. That's why we have entered the M02, that is N050 M02. Okay, M02 is for a end of the block. Okay, so if you see from N005 first two lines of the program, that is N005 and N010, this is, we can say, the program setup. Okay, and then from N015 to N040, it is for a chip removal. Okay, and the remaining N045 and N050 for a system shutdown. So in any part programming, three main parts are there. First one, program setup. Second one, chip removal. Third one is a system shutdown. Okay, so whenever you do the program, you are supposed to check three major parts. That means whether you set the program initially, that is by giving a spindle, by first of all changing the tool to your current tool, then a spindle start, and spindle's direction, whether it is in clockwise or anti-clockwise, also the its speed, and after that you whether you have finished the part 2, that is chip removal, mm, that it is going to remove the chips. Okay, that is in XYZ axis or direction. Okay, and you are supposed to check the third part of the part program, the system shutdown. Okay, that means you are supposed to give the code, that is spindle stop, end of the program. Okay, in such a way you must check while writing the program, or when you finish the any part programming, you are supposed to check these three major part. First one is program setup, second one is a chip removal, third one is a system shutdown. Okay, so in such a way you are supposed to do a part programming. Okay, here you can see the tool start position is given, but in many times what happens, they don't give. At that time you are supposed to assume, okay, the tool, and then you are supposed to do the programming. Okay, so I forgot one more thing that I said earlier, that I have taken initially the 5 mm depth. So you can take a 1 mm depth. Okay, and you can repeat it again 4 times. Initially first cut with 1 mm, and remaining 4 times the 1 mm cut. So total 5 cut having a 1 mm, that is, so total remove the material removed is of 5 mm. Okay, that is the total depth is 5 mm. So here you can do the programming for a milling operation. In our previous lecture we have seen the part programming for drilling operation, and before that we have seen the example of same part programming for a milling operation. Here our example is second example of part programming of a milling operation. Total, this is a third example of part programming for a milling operation. Okay, so in such a way you can do the part programming for a milling operation. Okay, and you are supposed to check three major parts: program setup, chip removal, and system shutdown. These are the three major important parts in any part programming, and you are supposed to write it properly. Okay, so now we are going to stop over here. Thank you.